Welcome to Tuesday Tech Talk, and this time we have two esteemed external guests from Crunchy Data, and they are experts at Postgres and everything Postgres. Anyway, they'll tell you all about it, and specifically they'll talk today about how their offering integrates with CloudFoundry and Pivotal CloudFoundry. Without much further ado, there is Paul Laurence and Robert Bates from Crunchy Data.
Hi, thank you everyone for having me, and thank you Pivotal and folks for inviting us to come in and talk today. So I'm Paul Laurence, I'm the co-founder at Crunchy Data. I have my distinguished guest Robert Bates, who is our Vice President of Sales Engineering, here to talk about our solution for Pivotal CloudFoundry. So we are Crunchy Data. We're the leading provider of trusted open source Postgres technology support and training. Our mission is to bring the benefits of open source PostgreSQL to the enterprise use case. For those who aren't familiar with Postgres, it's an open source relational database, oftentimes credited for its focus on data integrity, SQL compliance, security, a lot of the feature richness that enterprises look for as they look for alternatives to proprietary relational database technology like your Oracles, DB2s, and SQL servers. It's very much a community-driven capability or product. The Postgres community is a global community that is responsible for the innovation and primary development of the database technology, which is a fantastic in that it allows for rapid innovation. It also enables enterprises to confidently deploy the technology without concern of kind of a vendor lock-in problem that's associated with a single commercial vendor driving the technology. Postgres has fantastic extensibility, and as a consequence has a number of add-on features that are quite popular, whether it's PostGIS for geospatial data management, PLR, PostGIS is always a popular one, PLR, which allows the application of R analytic functions directly against data in the Postgres database, which is also popular and used for Greenplum. So folks who are familiar with Greenplum, it's the same extension that's used both for Postgres and Greenplum. And one of my colleagues, Joe Conway, is the primary author of that specific extension. And then Crunchy Data brings a lot of additional capabilities in terms of expertise and certain technologies to enable Postgres, cloud native Postgres, or Postgres as a service on various platforms, namely why we're here today, Pivotal CloudFoundry. So our model is very much, we're 100% committed to open source technology. We got our start, again, bringing open source Postgres to the enterprise as a means to reduce infrastructure costs and prevent the types of vendor lock-in that folks struggle with Oracle and similar. And as a consequence, open source, that commitment to open source is really critical to us, and it's critical to our customers. We are very focused on data security and compliance. Our start was in the US Department of Defense, where we did a considerable amount of work in terms of both developing features and capabilities within Postgres to support advanced security, things like row-level security or enhanced audit logging that enable meeting compliance regimes like Sarbanes-Oxley, HIPAA, Defense Information Systems, STIG, which we published in collaboration with DISA, and then Common Criteria, which is a international security standard that Crunchy Data, our distribution is Common Criteria certified, representing the first open source database to achieve that certification level. And then finally, again, cloud native, right? Bringing Postgres to your bread and butter Postgres, production ready enterprise Postgres clusters to cloud native CloudFoundry, which is gives you the benefit of production ready enterprise Postgres, whether it's in public cloud, private cloud, some combination of the both, cloud agnostic, leveraging the PCF foundation. Our team is quite active in the upstream Postgres development, and we have deep expertise in Postgres, which enables us to accomplish a lot of the things we're talking about. Guys like Tom Lane, Joe Conway, these guys are responsible for a big chunk of the upstream Postgres community development. Depending on how you slice the data, something like 30% of the commits. And then we have our own distribution that's at the core of a lot of the technologies we're talking about, which we refer to as Crunchy Postgres, which is importantly at its core completely unmodified open source Postgres, so that you have that confidence that you're not running a fork, you're not running a derivative of the database itself, you're running the upstream bits and consequently don't have to worry about vendor lock-in. And then we package that with a number of extensions, which again are popular in enterprise use cases, things like PostGIS, PG Audit, and other drivers. Our model is subscription-based, very similar to the Pivotal model. in that we provide 100% open source software, but we provide an enterprise support subscription, trusted packages and the like to our subscription customers. We also do project-based or long-term Postgres engineering, depending on requirements. And then perhaps most importantly for this crowd, we're a Pivotal partner. So we've been working with Pivotal for about 2 years now as a result of an engagement with a US government customer who selected Pivotal for their platform and selected Crunchy as the database provider and the Postgres provider, and was looking to solve the problem of database as a service, again, in a cloud agnostic and some combination of on-premise, private cloud, and public cloud use case, and wanted to use PCF as their platform to do that, to facilitate that capability. And so we started working with the folks at Pivotal to design a solution that brought the kind of bread and butter, HA, Postgres cluster to the PCF foundation, in enabling kind of an on-demand, self-provisioned HA Postgres cluster all through PCF. And so that's what we've been working on since the beginning of our partnership. It's we're quite happy with the results. It's now available in PivNet, and we've been is broadly receiving great reception. And so that's what we're here to talk about today, which we refer to as Crunchy Postgres for PCF. So the basic problem we are looking to solve with Crunchy Postgres for PCF, and the basic problem that was brought to us at our initial customer, was solving the kind of these dual concerns, right? The developer concerns, basically what they wanted to provide to their developers and their analysts was a easy to use self-provisioned database as a service, right? They just want to be able to point and click, in their internal environment and grab a database that's secure, consistent with other architectures, patched, all the good stuff that you would want from a database without having to expose any of the database complexity. From an operations and admin perspective, they wanted to prevent chaos, right? They want to be able to do this in a way that doesn't keep them up all night because they've got 1,000 Postgres databases floating out there that are each its own snowflake, and they're worried that people are running untold number of versions of Postgres. Are they patched? How are they setting their configuration parameters? What are they doing with backups? And so figuring out how to provide what the developers want, which is again, at risk of gross simplification, basically they want RDS functionality, but they don't want to be locked into RDS software or infrastructure. And so how do we accomplish that? And again, our solution is Crunchy Postgres for PCF. It's a fully BOSH deployed and managed Postgres as a service capability for CloudFoundry, 100% cloud agnostic. You can run it AWS, you can run it on-premise in vSphere, Azure, whatever your favorite public cloud is, as well as on-premise. It brings to you a lot of the enterprise functionalities that you would require, things like high availability, backup, restore, enhanced audit logging, that we hear from every enterprise customer we go talk to, right? When you're talking relational database or operational database type requirements, folks have a very standard set of requirements for those types of use cases. And so ensuring that we can bring all of those capabilities in an open source fashion to PCF in an on-demand fashion is really the primary problem we were looking to solve with this technology. It is currently available in PivNet, so you can go just download it and try it out. We also have a video on YouTube that shows kind of a basic introductory, getting to know the capability. So, and then under the hood, you'll see it's your traditional Postgres architecture, single primary, multiple replicas through some combination of usually synchronous or asynchronous replication to provide that high availability. And we have pre-wired backup and restore capability so that as you deploy your cluster, you have your high availability capabilities as well as your backup and restore. From a high availability perspective, again, Postgres supports native replication, both as synchronous and asynchronous. The typical architecture is you have a primary that accepts your read traffic, because Postgres is a single master or single primary architecture out of the box. And then you have some number of replicas, right, that are standbys that can be used for high availability purposes or DR. Postgres supports both synchronous and asynchronous replication, and usually what you'll see is some cluster, and again, what we have in the PCF tile is basically a configurable number of read replicas that you can use that are all load balanced, and so you can use for managing write traffic in order to scale up. how the HA works specifically is we leverage console to do the health checking on our cluster. And you see some of the kind of diagramming here, but the basic idea is that the console, you have a console node that's basically performing health checks against all of the infrastructure that's running your Postgres cluster, whether it's your load balancer, whether it's your Postgres nodes themselves. You have a load balancer that exposes your database endpoint, and your console is basically constantly checking the health of your primary database as well as your replicas. To the extent your primary falls over, or the health check fails, it comes back and tells you that we can't reach the master. Console immediately fences off that node, and to ensure that you don't have a corruption issue, or stoneth, for lack of a better word. And then basically reroutes your traffic, promotes one of your standbys to be the new master, and then reroutes your traffic accordingly so that your write traffic has a minimum interruption. And then once you've stabilized your cluster, so you're now accepting writes and you have a write that's replicating to one of your other standbys, it then heals the cluster. It generates a new replica, so you're back to your original steady state. And again, that's all through a combination of using Bosch Resurrector and console under the hood to make that all work as you would expect. And again, this is relatively standard Postgres HA architecture stuff that, again, we've specifically brought to Bosch to make it all Bosch managed and deployed. This is all running under the hood of the tile. You can configure the number of replicas, but otherwise we're taking care of all the plumbing here for you when you go connect to that load balance endpoint that PCF will give you. From a backup and restore perspective, we use a tool called PG Backrest. For those who are familiar with Postgres, it may be a familiar tool, but again, it's an a completely open source, high performance backup and restore capability that's authored by one of our colleagues, Dave. The primary author is a colleague, David Steele. It really gives you a lot of functionality from a backup and restore perspective, just generally speaking, full incremental differential backups, parallel backup and restore for high performance. It was originally developed to address issues with backing up very large Postgres databases. And so there's a lot of feature-rich capability that comes with PG Backrest as a capability. And again, it's what we would recommend if you just called Crunchy and said, hey, we need to do a traditional server install of Postgres. What do we do for backup restore? And so we've brought that to PCF. And so this is pre-wired in the tile that when you provision a Postgres cluster through PCF, you get PG Backrest is deployed as part of that process. And it's pre-wired to support weekly full backups and then daily incremental backups. So that, in that, again, that's all pre-configured. So every time you deploy a Postgres cluster, you have confidence that that cluster is being backed up appropriately. Again, full, and then a combination of full and incremental backups. From a security perspective, a topic that's, again, top of mind always at Crunchy, we've taken the initiative on a number of certifications to provide enterprises with the confidence that Postgres as a database technology has the security functionality that you would expect from a tier 1 database, right? A lot of times, I would say we get this question less today, but when we first got started, a lot of folks, enterprises would say, okay, we want to use Postgres. That sounds great. We were excited about the prospect of reducing our infrastructure costs, moving off Oracle, SQL Server, DB2. But what about security? We can't do that if it jeopardizes our security. So tell me about that, right? And so that drove us to go out and get Common Criteria certification, which is an international security standard that dictates a set of security functionality that is kind of deemed by kind of the broad-based database vendor ecosystem to be the kind of good housekeeping seal of approval. These are the types of security capabilities we'd expect from a relational database technology. And we went out and received kind of third-party validation, lab validation that Postgres can stand up to those requirements, leveraging both the core database server as well as this extension that we developed called PG Audit, which it provides the audit logging piece, which for a long time was missing in the upstream Postgres project. We also, for purposes of some of our specifically our DoD customers, but it also is actually been used by a number of folks in the commercial security-focused commercial enterprises as well, is we published a Postgres security technical implementation guide, which when we early on in the life of Crunchy, we would have large institutions come to us and say, hey, where do I go for best practices around using Postgres in a secure fashion? Well, here is a basically top to bottom guide in terms of the quote unquote hardening of Postgres for enterprise requirements. Now, some of this stuff is DoD specific, Department of Defense specific, but nonetheless, it still gives you a very good set of practices in terms of securing your Postgres environment to at least a standard that's been determined to be sufficient for DoD networks. And then we're currently working on, I think it's actually been published and it's available for community review at this point, a Center for Internet Security CIS benchmark for Postgres as well, which gives you a slightly more commercial version of the DISA STIG, or the DISA Postgres Security Technical Implementation Guide. And so this gives you a nice set of both documentation and the confidence of third-party lab validation of the security associated with Postgres. And in the case of Common Criteria and these Postgres STIG, in both cases represented the first open source database to achieve those standards or had to have a published guide. And we thought that was quite an accomplishment. Another kind of routinely asked for capability, or kind of the standard bread and butter in enterprise database requirements, metrics and monitoring collection. How do we integrate that with our alerting solution? The Crunchy solution, generally speaking, is we promote Prometheus Grafana, which I'm sure a lot of folks in the room are familiar with. It's kind of it's quite popular. It's written in Go, I believe, and quite popular in the kind of quote unquote cloud native ecosystem. So we've developed a set of templates and pre-configurations for Prometheus Grafana to support the types of metrics collection and monitoring that you would require for enterprise requirements. And then that can provide you with some out-of-the-box alerting, but it also can be integrated with third-party alerting tools to the extent there's already an enterprise alerting solution out there that you would like to integrate with. This is another one. Our analytics. I mentioned this a little bit at the top in terms of using Postgres for analytic workloads. This is similar to how Greenplum leverages R directly against a Greenplum database. You can actually use the same functionality against a Postgres database to leverage R functions directly against the database. We've done a lot of cool work here in terms of using the combination of R with geospatial to do geospatial analytics. And one of my colleagues, again, Joe Conway, has done a cool talk on that. If you're interested in that area, there's a lot of stuff on either videos or slides on the internet, and be happy to provide them. But generally speaking, this for folks who are in the analytics space and who like R, you can do a lot of cool. R needs no introduction, and this is an extension that specifically allows you to run R functions directly against Postgres, and it's something that we make available as part of our tile. And so that if that's a particular use case that's of interest, it's a pretty cool capability. Another capability that brings a number of users to Postgres specifically is PostGIS. To the extent you are not familiar with PostGIS, it enables geospatial data management within the Postgres database, and it's allows the management of geospatial data types. PostGIS is really one of the awesome capabilities of Postgres as a database. Oftentimes when you're talking about open source, you're playing catch up with proprietary data features. You say, okay, how do we do the same thing as we can do in Oracle today? PostGIS is generally considered to be the leading geospatial data management technology. So really a very cool capability for Postgres, and it brings a lot of folks to the Postgres database technology, generally speaking. PG admin, again, in terms of rounding out your toolbox for enterprise data management, what are the kinds of things folks ask for? One of the things many do look for is a GUI management capability for the database. How do you do things like Postgres, admin tools, maintenance, and want to interact with the database through a GUI rather than through command line? PG admin is generally considered to be the de facto solution for Postgres. We include PG admin 4 as a PCF app that you can deploy alongside of the tile to have the benefit of this for your that technology for your data management capability. And so that all together rounds out a pretty strong, again, out of the box Postgres as a service capability within the cloud native environment. And then we like to think about how do we take that a step further, right? So we've got the database as a service capability, but the increasingly reality is that folks, enterprises are looking to a data toolbox, right? You don't just have a relational database. You also want to have your kind of data warehouse, your analytics warehouse. Might be an enterprise that uses Greenplum as well, or Pivotal Cloud Cache, or some of these other technologies. They might have a Hadoop cluster. So how do we ensure that Postgres is a friendly component of that polyglot database environment? And so one of the things that we've been working on and we'll be releasing in the not too distant future is integration. So Postgres as a database has tools called foreign data wrappers, which allow you to use Postgres to reach out to external data stores and query and interact with those data stores as if they were a Postgres table. And so how do we leverage that to do more advanced kind of integrations with Postgres and third-party data stores? So one of which is Redis. So we've created the capability to basically integrate a crunchy Postgres tile, or interact with the crunchy Postgres tile in a programmatic way to go then use a foreign data wrapper to speak to an external Redis instance. And this is something that we'll be releasing a little bit later this year in the run-up to Spring 1. But will allow you basically through the Postgres tile to deploy a foreign data wrapper and go communicate with that Redis, which unlocks some cool use cases that we see in the field in terms of using Redis as a different type of data technology, but do hybrid type things like using it for caching or other layers. And so you can write to the Redis, you can persist in Postgres, and then again leverage the Postgres data for reporting and other kind of architectures. But it provides some cool architectures. We're also planning to do the same thing with Pivotal Cloud Cache, again as another tool in the toolbox, and also have looked at doing something similar with Greenplum, right? Because as probably everyone in this room knows, Greenplum has its heritage in Postgres, so it's a very nice fit in terms of the Postgres Greenplum interaction. And so for that, that's something we see out in the fields where folks have a very large, 100 petabytes of raw satellite data, but then they have a 10 terabyte PostGIS metadata cluster, right? And that's a pattern that we're seeing. And so thinking about how do we use PCF and some of the work we've done with the tile to make it easier to deploy kind of those standardized architectures, right? That go beyond just simply deploying a simple database as a service. And then finally, just a quick plug on PKS, right? So another area that Crunchy's done quite a bit of work is with bringing Postgres to Kubernetes and providing some of the similar functionality that we've talked about, HA clusters, backup, restore, using the Kubernetes infrastructure to accomplish that. And so when Pivotal announced Kubo and then most recently PKS, obviously this was something we were excited to be a part of and to expand our partnership. And so we are working with the various folks within the Pivotal engineering team to ensure that when Pivotal Container Service comes out, V1, which again I believe is coming out later this year, that we're ready to deploy the crunchy Postgres solution for Kubernetes to PKS, and it will be available to provide all the same types of functionality that we've just described on the PCF side. Any questions on that? I know we want to keep it tight on. Yep. Okay. Yeah. Yeah.
But you're not a fork. Do you merge all of the latest Postgres commits, like as the open source, like the Postgres open source community contributes, or do you contribute directly to that code line?
We do contribute. Yeah. So the question is, how do we interact with the Postgres project, given that we're saying we're not running a fork? What is our interaction with the Postgres community? So all of our Postgres server development occurs upstream. So we are involved in the Postgres has things called commit fests, where that's the kind of cycle where new Postgres features and capabilities are taken care of or developed and merged in the upstream code. And so that's something we're actively involved in upstream. Again, guys like Tom Lane, Stephen Frost, Joe Conway are committers to the Postgres project and that are part of the Crunchy team. We also have other folks on our team who are actively developing code and committing, but it all happens upstream. So we don't maintain a fork that we then merge up. We only package the actual upstream bits. Now, to the extent and then most of the bug fixes all occur upstream as well. Again, Tom Lane is personally involved in a wide variety of those, and so we have a very close relationship with the actual upstream project.
And I was just curious, what are the biggest obstacles you've had when trying to unlock disclosures becoming a PCF file?
Yeah, it's a great question. So Crunchy, what are the obstacles we saw? What were the challenges we saw in kind of building the Crunchy PCF capability? And I think from our perspective, when we first got started, we didn't know anything about Bosch. We're a Postgres company, right? At the end of the day, we're very good at Postgres. We didn't know anything about Bosch. So there's definitely a learning curve as you familiarize yourself with the Bosch technology. So that took some learning in terms of how do we replicate the same functionality that we would deploy in any sort of enterprise context within Bosch? How do you do things like backup restore? How do we get the HA working? HA is always a hard problem. Auto failover is always a hard problem. How do we get that working within the Bosch framework? So I would say it's just getting smart on Bosch was the learning curve. But once you've kind of figured that out, it's very powerful, right? There's a lot of functionality that we've been able to take advantage of in the PCF tile. Yep.
Since the publication of the Postgres stig, have you seen a notable increase in interest or adoption of Postgres among DoD customers?
So the question is, since the publication of the STIG, have we seen an uptick in Postgres usage specifically within the DoD? And I think the answer is I would say probably yes, right? I mean, I think the great news about Postgres is it is very pervasive technology and was, even before the STIG, was broadly used in development environments and in other places throughout the DoD. But because there was not yet a published STIG, actually deploying that in a production setting was a challenge, right? Because
as a former DoD,
yeah.
I've seen people basically say, we love the idea, but we can't use this technology because there's no STIG.
It puts a significant burden on the program or the developer to have that system approved running Postgres, because you basically have to go out and say and get waivers or to get some other approvals to say, okay, we think this is close enough to another database and we can leverage some other security guides. And so giving folks an easy to use capability in terms of a checklist is a big help. We've actually gone, and I'm glad you asked, we actually have gone a step further, and we've worked with Pivotal specifically as one of our joint government customers to automate the STIG compliance testing using a tool called Inspec. And I don't know, for folks who follow the space, we worked with MITRE as well on this, but it basically enables you to, in the risk of using the buzzword DevSecOps, right? You basically can provision this capability so it is constantly checking your provisioned Postgres clusters against the database STIG to ensure that not only are you STIG compliant upon the provisioning, but you also remain in compliance throughout the life of your cluster. And so again, this is pretty cool. It's a completely open source project, and you go grab it off GitHub, but it allows you to run a STIG check against your entire database. And again, you can integrate it with the DISA STIG viewer, and you get your red greens to figure out if that, if you're still in compliance. But I think that's reducing that burden, that security burden. I mean, there's an initiative we're working with Pivotal on that they call ATO in a day, or authority to operate in a day, is a lot of the value I think we can add through the PCF platform. Yep, of course.
How much did, for instance, Google Spanner play into your developing functions version of Postgres?
So the question is, what kind of influence does technologies like Google Spanner have, or the new SQL, I guess, is how you may describe that. So the answer is it's definitely relevant, right? I mean, it not so much in Crunchy's specific implementation, but in terms of the upstream Postgres project. I mean, Postgres itself understands that it needs to continue to innovate to remain relevant as new database technologies come out, right? You saw that with Postgres adopting some of the kind of NoSQL frameworks in terms of JSON data types. It's currently working upstream for things like parallelism, and to enhance the roadmap towards multi-node Postgres in terms of bidirectional replication. So there's a lot of innovation going on that will facilitate the types of use cases and capabilities that something like Google Spanner has. But obviously Google Spanner was developed out of the box with a very specific context in mind. So Postgres has to achieve those features from the foundation of a traditional server relational database, moving in that direction. Crunchy, I think we see our ability to bridge that gap in some respects by integrating with technologies like PCF to provide more of a cloud native experience. But we want to see the actual database feature development happen upstream. We don't want to run a fork. Our customers don't want a fork. They want to run the upstream project, and we want to enable that in cloud use cases. Of course.
Simple question. So you gave a lot of attention to that. Any database that spins up is conform to the company's requirements.
Yep.
Is there also an option in your tile to quickly spin up a test database that doesn't get replicated, that isn't necessarily reaching?
So the question is, what is there a capability to provision kind of a test or dev instance of our tile? Because obviously the tile itself comes with a lot of HA, it comes with a lot of infrastructure. Is there a way to do a simple? And so the answer is not right now. It has been a popular request though that folks who want to deploy the tile would like to have a simple non-HA, much more lightweight deployment for dev testing environments, and so that's something we anticipate coming out within the not too distant future. The idea would be to provide. Right now, you can configure the number of replicas. So if you could basically configure it down to 0, you have 0 replicas. You don't have HA, but you still have the same endpoint type infrastructure, so that it would, from a development perspective, it would look very much similar to what you were planning to provision in a production setting, but with running on a single or 2 VMs rather than a collection of VMs for the full production system. So yeah, it's been a popular request. So we're it's coming soon, so to speak.
So that leads me to how many VMs do you need for a
So we have I think 5 different plans in the tile currently. I think it's like small, medium, large, extra large, that kind of deal. I believe the small plan requires 7 VMs, but they're small node sizes. As you get to extra large, it's obviously quite large. So the idea is, how do you skinny that down, right? Because right now, currently, the architecture basically provides for a console node that's watching each of the other nodes in your cluster. So that inherently comes with some infrastructure requirements. So we're definitely looking at ways to how to skinny that down, and specifically for dev test environments as a starting point. And if you're willing to sacrifice HA, that makes life a lot easier, right? Yeah. Yep.
Besides the integration with Pivotal CloudFoundry, how do you guys differ with Cockroach TV?
Yeah, so Cockroach, I would put into the other, in the category of kind of new SQL technologies. I'm less familiar with the feature set of Cockroach DB, other than to say that I believe it is a specific implementation of the Google Spanner framework, so to speak, right? It's a commercial implementation of the Google Spanner kind of framework, technology, research, however you want to describe it. And so in that respect, it really is driving towards this use case of like massively consistent, scalable, nodes throughout kind of a specific cloud infrastructure. I think in doing that, they can make some certain assumptions that are, Postgres as a database is unlikely to accept certain assumptions that have driven the Spanner and the Cockroach DB research. But I think so that it's to some degree not apples to apples, right? Because we're solving a more traditional relational database capability and presenting that in a cloud environment versus a specifically designed from the ground up cloud, more designed to be a cloud database than Postgres was, obviously.
Any more questions? Well, thanks so much.
Thank you very much.